Welcome back. Today we will talk about congruent polygons and congruent triangles. Congruent polygons are two shapes that have all the corresponding parts are congruent. So the corresponding parts means that they're the same size and the same shape. This includes the angles and the sides must all be congruent. The abbreviation for triangles is CPCTC. This stands for the corresponding parts of congruent triangles are congruent. Since this is an if and only if statement, it means that it goes both ways. So if two polygons are congruent, then all the corresponding parts are congruent. And also if all the corresponding parts are congruent, that means that the two polygons are congruent. So let's look at an example of congruent triangles. This is triangle ABC and triangle HKJ. Now, first what we want to do is list out the corresponding angles. Basically, this means which pair of angles match up that are congruent. I can see angle K and angle C are congruent. Angle A and angle H are congruent. And finally, angle B and angle J are congruent. So let's list them out. Angle B is congruent to angle J. Angle A is congruent to angle H. And angle C is congruent to angle K. Next, we'll list the corresponding sides. I see that side BC corresponds to KJ because they are marked as congruent. Now, it's important to go in a certain order when we're listing these sides. So, since if I say CB, then I must go in the correct order. C corresponds to K, so I want to go in the order K, then J. Notice that the spot that the letters are in must show what corresponds. So C corresponds to K, since they're both in the first spot. B corresponds to J, since they're both in the second spot. Similarly, I could write AC is congruent to KH. Sorry, I meant HK. We have to make sure we keep it in order. So if I'm going A to C, I know I have to go H to K, because A and H correspond. And finally, I have BA is congruent to JH. Sometimes as a tip, it's also helpful to look at the angles that you already listed out. So for that one, I just looked at BA is congruent to JH. Now finally, we need to write a congruent statement. This basically shows the final answer, like what is congruent. So what I like to do is I just go off of my corresponding angles. So I'll say triangle BAC, I'll just go from top to bottom, is congruent to triangle, and I'll go the same order on the other side of my angles, JHK, from top to bottom. Now, double check always, your congruent statement must be in an order to show what's corresponding. So B corresponds to J, that's correct. B and J are corresponding. And then A corresponds to H, and C corresponds to K. In addition, you should know if you pick any two letters, these are corresponding. So segment BA corresponds to segment JH. That's seen here. Similarly, segment AC corresponds to segment HK, and segment BC corresponds to segment JK. So it's really important what order you put these letters in. You can't just randomly name the triangles. Pause the video and try the practice problem below. Here are the correct answers. I know that these polygons are congruent because they have all corresponding parts congruent, all the corresponding angles, and all the corresponding sides. Now let's say we know that these triangles are congruent. We're going to use the reverse. So knowing that they're congruent means that all the corresponding parts must be congruent. So these are listed in a certain order. Remember, when we see a congruent statement, it'll help us see what's corresponding. So I want to find the values of x and y. I see an x and a y on side FE. So I'm going to see what corresponds to FE. They're in the last two spots, so I know it must correspond to BC. So I'll circle those or highlight them or something in the same color or style so that I know they're corresponding. Also, I see angle F has a y variable. So I'm going to look at my congruent statement to figure out what corresponds to angle F. It's the letter in the middle, so I know it must correspond to angle B. Now that I have the two pieces that are corresponding, highlighted or circled or something of the sort, now I can set up an equation. I know angle B and angle F are corresponding. That means they must be congruent. Whenever angles are congruent, that means that their measures must be equal. So I know 8y minus 5 must be equal to 99. Similarly, I know FE and BC, those two segments, are congruent. Therefore, they must have equal measures. So 2y plus x must be equal to 38.4. Now I can solve these equations. I must solve this equation first because it only has one variable. Now that I have the value of y, I can plug it back in and use substitution in the second equation so that I'll only have one variable. So first I substituted in 13 for y, and then I multiplied 2 times 13 to get 26. Finally, subtract 26 on both sides to get 12.4 for x. Just as a refresher, you always want to look at your congruent statement to see what's corresponding. All right. Next, we're going to look at proving triangles congruent using the definition of congruent polygons. So in order to do that, we'll have to show that all three pairs of corresponding angles are congruent and also all three pairs of corresponding sides are congruent. This third angles theorem might be helpful here. It says that if two angles of one triangle are congruent to two angles of a second triangle, then the third angle in the first triangle is congruent to the third angle in the second triangle. So basically, if we already know that angle B and angle J are congruent, as shown in this picture here, and then we also already know angle C and angle K are congruent, then the leftover angles, angle A and angle L, must be congruent to each other as well. So if you already have two pairs of corresponding angles congruent, this will be really helpful because without any additional information, by third angles theorem, you could conclude that the third leftover angles, whatever pair has not been already said as congruent, must be congruent as well. Let's try this in a proof. So it says, given segment DE is congruent to segment GE, which is already shown in the picture, segment DF is congruent to segment GF. This is also already marked in the picture. Angle D is congruent to angle G. And angle DFE is congruent to angle GFE. That's already marked in the picture as well. We are trying to prove that triangle DEF, this triangle here, is congruent to triangle GEF, this triangle here. Sometimes if the triangles are touching, it is sometimes helpful to redraw the picture where the triangles are not touching. Especially if the triangles are overlapping, you will probably want to redraw your picture. So far I have angle D is congruent to angle G, DE is congruent to EG, DF is congruent to FG. Now, I also have DFE is congruent to EFG. Alright, so let's look at the proof. First, we're starting out with the given that these two pairs of segments are congruent. Next, it says to use the reflexive property of congruence. So let's look. What pair of segments am I missing as congruent? I'm missing EF and EF. Think about it. EF must be congruent to itself based on the reflexive property of congruence. So I'll fill in EF is congruent to EF for step 2. Now I'm also given already two pairs of congruent angles. Based on what I just learned above, I know that I could conclude that the third pair of angles, angle DEF and angle GEF, are congruent based on third angles theorem. Anytime I have two pairs of angles already congruent, I can say the third pair must be congruent by third angles theorem. Finally, now that I have three pairs of congruent sides and three pairs of congruent angles, I can conclude that the triangles are congruent by the definition of congruent polygons or congruent triangles. Alright, just as these properties, reflexive, symmetric, and transitive, work for congruent angles and congruent sides, they also work for congruent triangles. They're the same properties we've been working with since chapter 1, so they shouldn't seem too strange. Finally, I'd like you to reflect on this question today. Please explain, why does the order of vertices, why does it matter? Why is it important when you're naming congruent triangles? Please give an example to support your answer.